Your unit is about polynomials. And you've already been working with polynomials. You're writing all of this down on a separate piece of paper. Remember, we're doing 2 days worth of information today. So we have linear. That was our unit 1. Quadratic was our unit that we're going over right now. We'll talk about cubic during this unit and quartic. And it goes above quartic, but these are the degrees. This is degree 1. This is degree 2, degree 3, and degree 4. What does that mean? It means when you look at an equation, the highest exponent you see is a 1, 2, 3, or 4. An example would be like this. Y equals 3x plus 5. What is the exponent on the x? You don't see one, so what's the hidden exponent? 1. So it has a degree 1. So we say degree 1. It's also known as linear. These are interchangeable words. If they say what's the degree, you say degree 1. If they ask for the term, you say linear. Quadratic. Here's just a random example of quadratic. The highest exponent is 2, so it's quadratic. Again, this is just a random example. Cubic. And last one. Quartic. So again, saying degree 1, 2, 3, and 4 is interchangeable with the words linear, quadratic, cubic, and quartic. That's the first part of today. Now, if something is polynomials, 2 things can't happen. Polynomials cannot have negative exponents. They can never have negative exponents, and they can never have variables in the exponent position. A term that you learned probably in 8th grade, just as a reminder, if I gave you this, and I said to you, what degree is this? I would accept two things. What degree? So degree is you're looking for the highest exponent. So the highest exponent you see here is a 4. So this is degree 4. What else would I accept? I'd accept the term quartic. Can you guys say the word quartic, please? Okay, so those would be interchangeable and acceptable. Now, what if I said what's the leading coefficient? Oftentimes, students think the leading coefficient is just the first number in front. But first you have to write this in standard form. Standard form, as you know, means the highest exponent down to the lowest. So, and in fact, this one just happens to be reverse order. Standard form is the highest exponent down to the lowest. Once it's in standard form, we look for the number in front of the first variable. That's the leading coefficient. But in this case, I don't see a number. What number is hiding in front? A 1. So now we're going to talk about the zeros. And we're talking about the greatest possible, the maximum, but the key word here is possible. That means we haven't figured out yet if they're real or if they're complex. As a reminder, if we're talking quadratics and somebody said to you, just draw a picture of a quadratic function that has 2 real zeros. Here'd be an example. How do I know it has 2 real zeros? Because it crosses the x-axis how many times? Twice. If somebody said draw an example of a quadratic function with 1 real zero, There we go, touches it once. But what if they said no real zeros? Remember, no real zeros is the same. No real zeros is the same as 2 complex for quadratics. Here's an example of a quadratic, degree 2, with 2 complex and no zeros. Okay, so I'm going to show you some examples. Keep this in mind, okay? And we're going to analyze them to determine what could be the possible number of zeros, real zeros, and complex. Here's what you have to know. Anytime you solved an equation, you get an I answer. Don't you agree that the I answers generally look like this? I'll give you an example. 2 plus or minus 1i, or negative 3 plus or minus I squared of 14. Don't you agree there's always a plus or minus? Right? With quadratics, yes or no? Okay, so we're getting 2 i's. Here's my point. I's always come in pairs. I's always come in pairs. So if I show you this equation, so here's just one random equation, and I said, what's the possible number of real zeros? Can you circle right now the degree of this? Circle the degree. Hopefully you circled 4. So what degree is it? It's degree 4. What's another word you could say? Quartic. Good. So it's degree 4. This tells us always the possible number of real zeros. So how many possible real zeros? 4. So I'm just going to write possible. This is max possible real zeros. And then max possible complex zeros. And these have to come in pairs of 2, remember. So put 4 fingers out. If you have 4 fingers out, all I want to know is how many times can you group these into 2s? So there's a pair of 2, there's a pair of 2. Does everybody see that? So do you agree that all 4 can be put into pairs of 2? Yes or no? Okay, I can use all 4. I'll show you an example next where you cannot use all 4. Okay, last part here is odd or even. So we're going to look right now at the highest degree, which is 4. Is it an even number or odd number? Even, so circle even. And we'll talk about end behavior. We'll come back to this just a little bit later, okay? All right, here's another example. Instead of me writing all of this down, I'm just going to go, what is the maximum possible of real zeros? So I circle the highest degree. Whatever the highest degree is will always represent the maximum possible number of real zeros. So there's a possibility of having 7 real zeros. Now, how many possible, maximum possible of complex? Well, let's do this so it's visually understand, for everybody can understand visually. 1, 2, 3, 4, 5, 6, 7. So they have to go in pairs of 2 for complex. 2, 4, 6. So in this case, how many possible complex zeros could there be? 6. Is this an example of even or odd? Odd because the degree is odd. Okay, I'm going to write one more down. This time tell your partner. You don't have to put anything down on paper. Just talk to your partner. Okay, to your partner. You ready? First question, maximum possible real zeros. Go ahead. Okay, next question, maximum possible complex zeros. Even or odd? Okay, let's go Felix. What's the maximum? Please listen. Felix, what is the maximum number of real zeros that are possible? 8. Close, but real zeros is as the degree you see. So what's the degree you see? 9. So your possible real zeros is 9. And Jesus, maximum possible complex solutions or complex zeros? 8. Because I can take a total of 4 pairs, which is 8 complex numbers out of that. And then this is an example of odd. Okay? 2 more concepts for this. So I'm going to flip my paper over. Grab your graphing calculator, please. Do second plus 712. Okay, so we're going to start with a basic even function. Let's just keep it real simple. We're going to do y equals x squared. Okay, hold on here. And then we're going to do y equals negative x squared. I want all females to plug this in. I want all males to plug this in. You have 15 seconds to get a graph. Ready? All females, all males. Go. You don't have to change the windows at all. Just graph it. Okay, for those that did x squared, does your graph look something like this? Yes or no? Okay, notice, is this even or odd? So write even and just do a really simple sketch for me. Even and a simple sketch. It's even, but by the way, this is even as well, but it looks like this. What is the difference between the 2 equations that makes it look different? There's a negative. There's a special word for that negative. That's 2 words. Starts with an L. Leading coefficient. What is the leading coefficient here? 1. It's a positive number. Okay, so I'm going to abbreviate just to make life simple. Leading coefficient is positive. It opens up. Leading coefficient is negative. It opens down. Good so far? Okay, this time, decide who's on the left and who's on the right while I make another one. Instead of doing boys and girls, left and right. The person who's sitting on the left, I would like you to do this one. So we're just doing another even. Another even and positive. And person sitting on the right, so left and right looks like this. Okay, go ahead and graph. If you're wondering how to plug this in, you're going to plug in x, hit the caret key, which is above the division sign, and a 4. Is there any major difference in these graphs? Major differences? There's no major differences, okay? No major differences. So here's the thing. You ready? Please listen closely. We can make an assumption here. If the degree is, so we're going to make an assumption. You ready? If the degree, you are putting this on paper, is even. If the degree is even, and we have a positive leading coefficient, so hopefully I'm spelling that right, I-C-I-E-N-T. Okay, if it is degree is even and you have a positive leading coefficient, both ends go up. If you have a negative leading coefficient, both ends go down. So if I said this, you ready? You're going to use your hands. And if I said this, I made up this random equation like y equals negative 3x to the 6th. Can we expect both ends to go up, or can we expect both ends to go down? Turn to your partner, go. It's even, so it's one of these two, but since it's a negative leading coefficient, they're both going to go down. Okay, flip to the next page if you need to, like I do. Okay, we're now going to talk about negative. Here we go. Or odd. My fault, odd degrees. So Let's start with y equals x to the third. Y equals negative x to the third. Decide which partner is going to do the positive leading coefficient, which one's going to do the negative. Go ahead. Okay, you have 15 seconds to get them done. Go, go, go. So what is the difference here? If it's positive, if it is a positive leading coefficient and odd, it goes up on the right and down on the left. You have to have this down on paper, otherwise you will not know how to do today's work. But if it is a negative x to the third or any degree that's odd, it's up on the left and down on the right. Okay, you're going to do hand gestures. You have 4 options. Everybody look at me right now. Okay, you have 4 things to memorize extremely fast. Ready? Here's one option. Just put 2 hands up really quick. Put 2 hands down. Okay, one option, put your right hand up, only right hand. If you don't know rights, look at your partner. Okay, now only put your left hand up. I'm going to write down a random equation. You have to analyze 2 things. You have to look and see what is the degree and what's the leading coefficient. Feel free to look back in your notes, and then you're going to do this, this, no robot dancing, this or this. Okay, does everybody understand? As soon as you know, you flip up the sign. Okay, here we go. As soon as you know, hands go up. Okay, here we go. You ready? So here's my first thing. Is this even or odd? Odd. So I'm only looking at odds right now. Odds mean either my right hand is up or my left hand is up, but not both. Is it a positive or negative leading coefficient? Negative leading coefficient, which means your left hand should be up, your right hand should be down. Okay, turn to your partner real quick to make sure they understand the concept. As soon as you know, do the signs with your hands. Even or odd? Even. Positive or negative leading coefficient? Both hands should be up in the air. Okay? Can I have a thumbs up or thumbs down if you're understanding that concept? You have only one concept left for this today. It's called multiplicities. You're going to write down this word. Even or odd multiplicities. Let me make sure I spell that right. Let's go back here. Even or odd. Give me 1 second. To my next page. Even or odd multiplicities. Now this is something where kids like get it within 3 seconds or it may take a few minutes because it's analyzing, you're not doing any work. Here's what this means. Odd means it cuts through x-axis. Even means it bounces off x-axis. Okay, I'm going to draw a picture to illustrate this. All right. So if I said to you, how many x-intercepts do you see? You'd say 1, 2, 3, and 4. Just so I understand, can you raise your hand if you recognize this as being x-intercepts? Hands up high if you do. Okay. So the next thing is we just need to analyze every x-intercept as being even or odd. Even bounces off, so it touches it and goes in the same direction it came from. Odd cuts through. So does this cut through the x-axis or does it bounce off? Okay, so if it cuts, it is what? Even or odd? Odd. So odd, this one is, because it cuts through. This one cuts through, so it is. Odd. But see how this one bounces off? So it comes down, it's like it touches the x-axis and goes in the same direction it came from. This is even. Please do me a favor and find for me this page right here. It is in your packet. Look at the title. Okay, is everybody ready? Okay, so how many zeros do we have here? So we are going to start by circling the zeros. Please put a circle here and a circle at this position. So how many zeros do I see? Real zeros. I see 2. Now we need to determine the end behavior. Is it even or odd? So remember, even degrees will either both go up or they'll both go down. But odds will have like one arm up and the other arm up. So look at the end behavior here. Looking at the end behavior, this is going down, by the way, at the same time it's being pulled to the left. It's going up at the same time it's being pulled to the right. So because one arm is up and the other arm is down, would we say this is even or odd degree? This is odd degree. Now, because the right is up and the left is down, turn to your partner instead of telling me, would you classify this as having a leading coefficient that's positive or negative? Feel free to look in your notes. This is positive. Up on the right, down on the left is an example of positive. Okay, then follow this. As you go to the left, that is what this is saying. As you go to the far left, so go to the far left, is your function going up or down or staying constant at one value? It is going down. As you analyze this degree going to this function going to the far right, as you go to the far right, is it going up or down? Please flip your paper over. Yasmin, when you look at the equation in number 5, do you think this is in proper standard form? No. Why not, Yasmin? Right. There's a higher exponent that should be in front. So we're going to rewrite this. F of x equals highest exponent, that term comes first. Remember, in order for something to be a polynomial, there's 2 things that can't happen. It cannot have negative exponents or variables in the exponent position. Can everybody look at number 6? Does everybody see how we have a variable in the exponent position? Okay, just write not a polynomial. And we often use the word poly for short for polynomial if you want to be lazy. Okay, degree. What is the highest degree you see? What is the highest exponent? So you could say 4. When it says function type, they're looking for the word quartic. And what is the leading coefficient on the x to the 4th? Done. So again, if you have a variable that is negative or negative exponent or a variable in the exponent's point, you just put not a polynomial, you don't do that problem. Go on to number 9, please. Please circle the degree in number 9. Please circle the degree. The maximum number of possible real zeros is always the degree you see. So for this problem, how many real zeros are possible? There are 4. Now I'm going to write 4 lines here just so that you can see. So how many groups of 2 can I make? I can make 2 groups of 2, which gives you a total of 4 possible complex. The easy way to think of complex is if you have an odd number, the possible number of complex is always just 1 less than that. Okay, is this even or odd? Now here's the tricky part. I want you to just make a really small graph off to the right. Really small. If it's even, both go up or both go down? Clarelli, would both go up or both go down based on the leading coefficient in this problem? Okay, and how did you come to that decision that one's up and one's down?
Because the leading coefficient is negative.
Okay, what is the degree?
4.
Degree is even. So look at your notes really quick and find even. That's okay. Find even. If they're even, what happens, guys? They both go up or they both go down. Because this is negative, they're both going to go down. That's okay. Okay, here we go. End behavior. So I have my little picture. As I go to the left, so I go to the far left, which direction is this going in? Up or down? Down. And as I go to the far right, which way is the arrows pointed? Down again.